Small rural water systems are often contaminated with bacteria by animals. I'm not trying to pick on cows here at all. It just happens on farms, happens with any kind of animal. So suppose we have a pond that's infested with 100,000 E. coli bacteria. In this pond, the colony doubles in number every 4 days. I'm asking you to use exponents to represent the number of bacteria in the pond in 24 days. And that's assuming there's no limits to growth. And that often will happen in situations like this. We're going to get some ridiculously huge number of bacteria, but that never really happens in real life because eventually the amount of food will run out and the bacteria growth will slow down, or overcrowding will mean that the bacteria don't have enough room to grow, and stuff like that will limit the growth. But assuming no growth, we'll come up with an answer. We're going to write that first in exponential form using exponents, and then express the number of bacteria in standard or expanded form, which is actually coming up with an actual number. Lots of times when we see questions like this, you can think, my goodness, I have no clue. I don't know what to do. Is there some kind of a formula? The thing is, there is a formula, but without knowing it, what I'm really interested in using right here for this problem is the perspiration method. And I will contrast that throughout the year with the inspiration method. And one is not necessarily better than the other. Sometimes the perspiration method will get you to an answer really, really quickly. And if it's just a one-off problem where you're just trying to come up with an answer, then there's nothing wrong with using it. If you're going to do this kind of problem over and over and over and over and over again, you might want to think a little bit more about it and come up with a set method that you can use so that you can be more efficient. But for now, let's just use perspiration. So we start off with 100,000 bacteria, so that's at the start. We know in 4 days the amount of bacteria is going to double, so instead of actually multiplying that out, because I want to use exponents, I'm going to do it this way. And often that's an important part of looking for patterns. We can disguise what we're looking for by multiplying the numbers out, but if I leave them this way where I can see clearly what's going on, that can often be really helpful for me to see the pattern. After another 4 days, so now we're at a time of 8 days, it's going to double again. So I'm going to take my original answer and I'm going to multiply it by 2 again. And because I know how exponents work, I'm going to write that as 2 squared. It's a shorthand. Rather than writing 2 times 2, I can write that as 2 squared. After another 4 days, so now in 12 days' time, and I'm sure you've already seen the pattern, I'm going to take this answer and multiply by 2 again. So I'm going to get 2 to the 3rd power. After another 4 days, so now we're at 16 days, we're going to get 100,000 times 2 to the 4th. It's going to double again. I'm going to multiply it by 2 once more. Need to do this 2 more times. So 100,000 times 2 to the 5th, and 24, it's going to be 100,000 times 2 to the 6th. Okay, so here's one practical use for an exponent. An exponent is simply a way of representing a repeated multiplication. This is not math anymore. This is something that somebody made up. If I wasn't using exponents here, I would have been forced to do this. And it just gets cumbersome. It just gets to be a pain. Mathematicians, above all, no, not above all, but they definitely try to do things efficiently and effectively. So they would never, they'd think, well, there's got to be some other way of writing that. And who knows, somebody might have said, well, let's do it this way, 2 6 times. Or somebody might have said, well, let's do it this way, or 2.6. Or this is just a notation that somebody made up. So it's not necessarily math per se. We just have to go with it because someone said, well, the way that we're going to show that repeated multiplication is to use a superscript. Okay, so there's our first step. After 24 days, we're going to have 100,000 times 2 to the 6th. Now, in standard form, we want to actually do that multiplication. So it's going to be 100,000 and 2 to the 6th power. You could use your calculator. I know that's 2, 4, 8, 16, 32, 64. So it's going to be 100,000 times 64. So it's going to be 64 and then put 5 zeros there. So 1, 2, 3, 4, 5. Shouldn't be using commas here, but I will anyway to make it clear. So after 24 days, assuming there's no limits on growth, there will be 6,400,000 bacteria present.